Understanding programming language generations.
Programming languages have evolved over decades to suit different needs and technologies. They're often classified into generations, from 1GL to 5GL, each marking significant changes in how we communicate with computers. Let's explore what defines each generation and why this classification matters for anyone interested in programming or tech careers.
First and second generation languages, machine and assembly.
The first generation languages, 1GL, are the earliest programming languages, the raw binary code or machine language understood directly by computers. The second generation languages, 2GL, known as assembly languages, use short codes or mnemonics to represent machine instructions, making them slightly easier for humans to write and understand.
Third generation languages, high-level programming.
The third generation languages, or 3GL, brought a leap in usability. Examples include C, Java, and Python. These languages use syntax closer to human language and abstract away most hardware details. 3GLs made programming more accessible, improved productivity, and laid the groundwork for modern application development.
Fourth generation languages, problem-oriented and productive.
Fourth generation languages, 4GL, focus on solving specific problems efficiently. They're used for database queries, report generation, and rapid application development. Examples include SQL and MATLAB. 4GLs are designed to be even more user-friendly, allowing people to write less code to accomplish more.
Fifth generation languages, logic and artificial intelligence.
Fifth generation languages, 5GL, are associated with artificial intelligence and logic-based problem solving. Rather than giving step-by-step instructions, programmers state the desired outcome, and the language figures out how to achieve it. Prolog and some AI platforms represent this generation, emphasizing declarative programming.
Why programming generations matter today.
Understanding programming language generations helps you navigate the tech landscape and choose the right tools for your goals. While newer generations provide greater abstraction and efficiency, earlier generations remain important for understanding computer fundamentals and optimizing performance. Each generation plays a vital role in building today's software and shaping tomorrow's innovations.